Here we have the engineering assembly for the exoskeleton leg. We have our fixed point as our hip 1 bottom print. Then we have our hip top, our knee top, knee bottom, ankle rod, ankle, and adjustable feet 1 and 2. So our mates are going to be, we have up here at the top, we have a coincident mate with hip 2 to insert it into the socket of hip 1, as well as a concentric mate to insert it in so it rotates about the point, as it is considered sort of a pin, that it's allowed to rotate in the socket. However, you can use lock rotation to prevent that. Then we have a coincident mate right here between the hip 1 bottom and hip top, as well as another coincident mate right here. So these two lock into place so it can't rotate in any way, and it's defined. Um, and then down here between hip 1 and hip 2, we have a coincident mate between between the inner hole and outer hole to lock it from moving on the Z axis. And then we also have a parallel between these two faces here, and this sets it from shifting in our X, and that locks this into place and fully defines it. So then we also have our concentric mate right here between our knee rod and our knee male and knee female. And so this keeps it from shifting on the Y and the X. And then we have another concentric mates in the inserts for the ankle rod, and another concentric between the adjustable foot and the ankle lower, and this locks both of those as well in the Y and the X direction. Then we have a coincident right here for the foot adjustable. This prevents the foot adjustable from being able to swing at an angle. And then as well we have a coincident between the two straight lines of the corner here on the foot, and this allows us to lock it into motion on the X and the Y as well. Then going back up here, we have a concentric mate between the two surfaces on this, as well as a coincident between the faces of the knee male and female, and this keeps it from shifting in our Y direction. Then we also set it parallel here, and this keeps it from shifting in our um, X, Y, our X and Y direction, as well as a parallel down here, which keeps our ankle rod and knee lower from shifting the XY as well with the parallel mate. And we have a concentric mate here, which is going to keep it from shifting the Z. This is going to lock it so that these two holes line up nice right here and perfectly lined where a pin can be inserted. That's what all these concentric mates are essentially allowing, is for them to line up very nicely so that we can insert a pin through when we 3D print it. Then we have coincident mates between the faces of the knee male slash knee lower and the face of the ankle rod, and this is going to keep us from shifting in the X direction and the Y direction in tandem with a parallel line between the foot and the ankle rod, and this is going to keep our whole assembly, it's going to keep it parallel so everything lines up when you look from above, and from the sides everything is completely lined up thanks to all these parallel mates we've set. Keeps it from locking. Then we have a concentric mate here, and this is going to once again keep it nice and lined up so a pin can be inserted through. Then we have a coincident mate here, which is keeping anything from shifting in our X and Y as well, and another coincident, and those two in tandem prevent any shifting in the X and Y. So a lot of the coincidents are used to keep the XY from shifting, the parallels as well in tandem with those coincidents, and then the concentrics are allowing the two holes to line up nicely for pins. We do use coincidence here as well to keep the shifting of the XY up there. We can use concentric lock to keep the hip 2 from shifting, and that'll give it a fully defined feature. However, you can unlock it and have rotation. That is technically still correct. And then we set a plane from one of our faces and then used a mirror component. So this is actually a mirror across that plane. So you only need the mates for one side because the mates will mirror over and it'll lock it as well on that side. And that is our total exoskeleton system assembly. And it fully defines with our fixed point being the hip rod.